Hello children, welcome to channel Sube. Children, today I am going to discuss question number 22 from the MCQ part of 2022-23 Physics New Syllabus paper. A triangular shaped portion QBR is removed from a uniform square sheet PQRS and connected to form the composite sheet PQB'RS as shown in the figure. The center of the gravity of the composite sheet is most likely to be at A, B, C, D, E. A, B, C, D, E. So children, let us try this question. Let us first of all magnify the given diagram. So the story is like this. Previously we had a square sheet like this. So from this sheet we separated, detached this portion, this triangle, and fixed it here outside of this previous square like this. So now the final sheet is like this. There is a hole here like this because we removed that part to the outside. So children, without calculation even we can do this easily. So now you get the idea. So I remove the colors. We go to the previous state. It was like this. So to solve this, before we remove that triangle part, it was like this. The square was like this. So the center of gravity of this square previously should be here at the center point, because all the portions are there. The full square is there. So the center, at the center, the center of gravity is there at the center. So it is here. It was here. So now when we remove this part, what happens? When we remove this part, the center of gravity doesn't stay here. When we remove this triangular piece, the center of gravity shifts to the heavier side. The plate material on this side was removed and the plate material on this side is still there. We have removed material on this side. So the weight on this side is reduced. The weight on the other side is still the same. The parts of the sheet we removed. So the weight is given by these material parts. So therefore the material parts are now at left side. Before that it was here as well. Now the materials are at left side, more to the left. The center of gravity is pushed to the heavier side. So the center of gravity doesn't stay at this place, it moves here to the material direction. So like this, it may be somewhere here. It may be somewhere here. So after that what we do, we attached that triangle which was removed from the square from the outside like this. So the weight here at this side is now greater than not than this side, but still this side is heavier. But before that there was no such a triangle here, but now there is a extra triangle here at the right side. So from this place, previously we discussed the center of gravity was here. So now it again goes to the direction where more materials are. So here the additional weight, due to the additional weight of this right side, this center of gravity again moves to this direction. So it most probably it might come to this place. It might come to this place. The center of gravity cannot be at this point. For some reason, this triangular part that used to be there is no longer here. If that piece had been here, the center of gravity would have been right here. If this removed triangle also, if it were there, the center of gravity would have been here, might be at the center, but here this part also not there now, and also additionally there is another triangle outside of that. Therefore this one moves to that direction. Therefore the most probably the center of gravity is here now. So the final center of gravity is this one now. So if you are used to do these types of problems, at first glance you can understand that this one is the new center of gravity. So the answer is this one, third one. So the question number is 22. Let us check. 22, 20, 22, third one. Third one is correct. This one is the answer. So if you think, if you don't happy about this explanation, if you want to calculate, so let us do it. We can calculate it like this. First of all, we have to calculate the center of gravity of this part. Center of gravity of this part without this triangle. Without this triangle, we have to calculate the center of gravity of remaining part. So how to do it? We have to separate, we have to mark these other triangles also, like this. So now what we are going to do, this ash color, the center of, to find out the center of gravity of this ash color plate, which is now remaining, the remaining one. So we marked it like this, into same shapes of triangles, because then we can compare. So these two, now focus your mind to these two parts. So they are symmetrical. Since they are symmetrical, the center of gravity of these two, only of these two without this one, of these two should be here at the center, because due to center of due to symmetric, this one is the center of gravity of these parts. So now how to find out this ash color triangle, the center of gravity of ash color triangle. So you have to connect the at the center of this side with this vertex, so like this, and get another vertex and the center of that side. So the crossing point is the center of gravity. So the center of gravity of this triangle is somewhere here. So now we have to use these 2 points to find out the center of gravity of this complicated sheet. So how to do it? We have to connect now these 2 points already that we have found, like this. So this distance, let us see now how we divide. The weight of these 2 triangles is acting at its center of gravity, like this. Suppose the weight of this one is W and weight of this one is W, so 2 times W weight is there at these at the center of gravity of these 2 parts, showing in blue color. So the center of gravity is this one of this ash color one. So from there, from that point, there is a weight. There is a weight. So that is W in magnitude. That is W. So let us use red color. It is not visible. So like this, 2 times W, because this one is only W, 1 W. So the weight of that is W. So here this center of gravity, this point is the center of gravity of these two triangles. So the total weight of these two triangles is 2 times W. So therefore it is acting from this its center of gravity. So 2 times W. So now we have to divide this distance into 2W plus 1W. 2W plus 1W is 3W. Just say 3. We don't want to use W. 3. So we have to divide it into 3. Into 3, because we are going to get the ratio, but inverse ratio. So this line we divide into 3 like this. 1, 2, 3. 1, 2, 3. 1, 2, 3. So the total distance we divide into 3, because there are 2 parts, there are 1 part, there is 1 part. So altogether 3 parts. And inversely we have to take the distance. So here 2 times W. So we don't get from this point to 2 pieces, but we get it inversely from other point 2 pieces towards the direction of the line. So this one is the final center of gravity. This one is the final center of gravity of these 3 triangles. These 3 triangles, because so again I am going to explain. So since there are 2 parts here, we get from the other side. From the other side means this side 2 parts. 2 parts. Then the point is this one. So this one is the final center of gravity of these all 3 triangles. So now we have to consider the external part. So now let us again take a copy, and I will clean these not necessary things. Right. So the final center of gravity is at this place, of all these three triangles. This is the final center of gravity, the point of center of gravity. Now we have to consider the other one, this one. I color it using red color like this. So now the center of gravity of this triangle we have to again find out and consider with this center of gravity. There are two, now going to be two. So again we join this vertex and this point, the center point of this, midpoint of this side, and also this vertex and center midpoint of this side. So the crossing point is the center of gravity of that triangle. So it is somewhere here, somewhere here, like this. So now again we have to consider the weights of these pieces. So here there is a weight of one triangle. We assumed that the weight of one triangle is how much? W. So we write here W. Then again we have to consider the weight acting on this center of gravity. Previously we found it, the place. So the weight acting on this center of gravity is, there are three triangles. This center of gravity owns to these three triangles. So therefore 3 times W is the weight. Then again what we have to find out, the final center of gravity of these two parts, red color one and ash color one. So let us connect the center of gravity lines. What the color we use? So this one is, this yellow is good. So this line, now how we divide? 3W plus 1W, 4W. That means we have to divide it into 4. So this is the midpoint, roughly midpoint. So again divide into 2 like this, So we have to take inversely 3 times weight here, but the length from this side we have to take 3 times, not from this side. From other side we have to take 3 times length. So that means here from here 1, 2, 3. So this is the final place. This is the final center of gravity point of this compound sheet. So that means C. The answer is C. So that is why we chose previously this. So children, here is our target question number 1. A triangular shaped portion QBR is removed from a uniform viscous sheet PQRS. The center of the gravity of the remaining sheet is most likely to be at A, B, C, D, E. So try to solve it on your own without looking at my answer. Pause the video first and try then. Since you have paused the video, now I am going to try to solve this. So let us get a copy enlarged. Something more. So we have to find out the center of gravity of this sheet. So let us consider these two first, this one and this one. So the center of gravity of these two, only these two, is located at this place, at the center. Due to symmetry, the center of gravity must lay at the center of these both sheets. So now we have to consider this other one, the ash color one. So to find out the center of gravity of this sheet alone, we have to connect the vertex of that sheet with the midpoint of that side, and also this vertex and this midpoint, midpoint of this side, like this. So the center of gravity is here. So now we have to connect those two points using a line like this, and now consider the weights. This point has a weight of 2 times 2wo, just 2 is enough. This one is 1, this one is 1, and all this one is also 1. But here, according to the only we are taking these two, because this center of gravity point ons to these blue color sheets only. So therefore 2, weight is 2. So the weight acting on this point is only 1 triangle. So altogether 3. Therefore we have to divide this line into 3 parts. 1, 2, 3. 1, 2, 3. Roughly like that. 1, 2, 3. So we don't take, since this one is 1, we don't take from this side 1, but we take from other side 1 part, because inversely we have to do it inversely. So now the final center of gravity is located at here, like this. This is the final center of gravity point. This one, that means B. The answer is B. Answer is B. They have given A, B, C, D, E. So the answer is B. Here in the original question, there is no point here. At the crossing place, there is no point. There is no answer. A is here, B is here, C is here, D is here, E is here. So therefore, the previously we marked this, but there is no black dot, only a yellow dot here. I marked this one, not in the question it was. Then the answer is B. What happened to your answer? Successful. If it is successful, you are genius. If not, you have to follow again these types of questions, and from here you have to come back. So let us go to the next target question number 2. Children, here is our next target question number 2. Read the question and try to solve it. Pause the video. Try to solve it on your own, honestly. So since you have paused the video, now I am going to start. We can divide into triangle pieces, because the problem is about a triangle. What is moved here and there is triangle. So therefore we have to consider other parts also as triangles, then we can get easily the weight. So now there are 3-4 triangles like this. Easiest way, we can consider these two first. These two first. the center of gravity of these two must be here at the center, because due to symmetry this one must be the center of gravity of these two. Then let us consider these two triangles. Let us use red color. What is the center of gravity? Where the center of gravity of these two? Previously we did, in the previous question we did. So due to symmetry, the center of gravity must be here of these two. So what are the weights acting on these 2 points? The weights on this point is 2 times 1 2 triangles, therefore 2. The weight on this triangle, this point, is how much? That also is equal to 2, because 1 2 only red triangles we consider here regarding this point. So one triangle is we take as 1, so 1 2 2, so here 1 2 2. So that means weights are same, equal, therefore this line should be divided into, and we don't have to go such a long way, just we can divide this into 2 pieces, because equal. If the weights are equal, the balancing point is at the center. Or otherwise, if you want to follow the same theory, so here 2 altogether 4, we have to divide this into 4, into 2 divided and 4, like this. And if we started from here there is a 2, but we take it from this side. 2 we take it from this side. So from this side we take 2 pieces, so final point is this one. So therefore the final center of gravity is located here at the point D, at point D. The answer is then D. Answer is D. So this one, the fourth one, is the answer. What happened to your answer? Successful. If you are successful, you are genius. Otherwise you have to do several times the same question. You do several times, at least 5 times, then it will go into your head, and then it will be easier for you to solve successfully. So children, I think you are happy. I tried to teach you understand, so that you understand using colors and everything like this. I think I taught you clearly. So I think you are happy. If you are happy, what you have to do, if you haven't still subscribed to my channel, please do it right now and share my link among your friends, so that I get a bigger audience, and press the bell icon so that you get the message as soon as I uploaded, and also press the thumb up icon and give me a like. I don't want likes, but I want a like, because otherwise this video doesn't push forward by the YouTube. It will go somewhere to a corner. So therefore please press the thumb up icon, then this video will be famous. So children, leave the page without owing me. So see you tomorrow in the evening at 6 o'clock. Children, so long, goodbye.